Okay, so I just wanted to show you this last little bit of 3.5. So we're going to kind of go with 3.5, 6, 7, and 8. So there's one more interesting thing to notice with long division of polynomials. Look back at problems 5b, right? Did we do 5b? We did not. That's okay. And let's look at this and the fact that f of 2 and compare the remainder when you do that. So the very first thing that we're going to do is I'm going to have you practice this, and you've already written it. So I'm going to give you a couple of seconds to do this really quick, and then I'm going to show you what they want. Actually, you're going to see on your own. Okay, so go ahead and do this problem and divide it all out, and we'll meet back in just like a minute. Okay, so what we're going to do is divide this, and you've already seen the division over and over again. We're just solidifying our learning. All right. So we go x cubed minus 4x squared plus 2x plus 5. Check Miss Johnson because she copies things wrong, and you should always check it anyway. So x cubed minus 4x squared plus 2x plus 5 divided by x minus 2. I'm going to kind of fly through this because you guys already know how to do this. So again, you're asking yourself how many x's go into x cubed, or x cubed divided by x is x squared. So this is x squared, and then I multiply out x squared. So this is x cubed minus 2x squared. And then I go through and I'm subtracting, right? So then I have to add the opposite. So I just change everybody's sign. I know I did it right because these two cancel out, right? So hold on, it's going to change the signs. So yeah, these two cancel out. And so then I'm going to be left with negative 2x squared plus 2x plus 5. Again, this is like one of those things that I will tell you over and over again. If you're not practicing along with me, this is why you get confused. So if you're not doing these problems before when I give you guys time, again, that's probably why the grade isn't what you want it to be. Okay, this is not like I can watch someone else ride a bike and be like, oh, I understand how to do it. This is really one of those get your hands dirty and, write down the stuff, because your brain needs to practice creating this stuff. So again, you say x times what will give me negative 2x squared. So then you're like, oh, that's minus 2x, I think. And then you say, and then you check, you're like, negative 2x times x, that's negative 2x squared. You know you did it right when these two numbers match. Okay, because when I add the opposite, then I will see them. Okay, then we go negative 2x times negative 2 is positive 4x, right? And then, so then when you're adding the opposite, so we're going to subtract. So then we add the opposite. So we add our opposites, right? And then, so we get those two to cancel, again, indicating that I'm right. I'm always going to show you exactly where, no worries, that's fine. Exactly where to check that you're on the right road. Because it'd be horrible if you did all this math and be like, shoot, I messed up here, right? So always look for these small checks that's verifying that you're right. I'm a huge fan of checking things along the way as opposed to, at the very, very end. So then I bring this down, negative 6x plus 5. And then, so then I divide negative 6x by x, and I get minus 6, right? And then, so I do it again, negative 6x, and then I get negative 6 times negative 2 is positive 12. And then I add the opposites. So this is negative 7. Okay. Check my math, because Miss Johnson, she makes mistakes in math. Sometimes on purpose to highlight so that you guys can point out, hey, Miss Johnson, I think you made an error here. Like, oh, that's right, I did make an error. But then sometimes it's because I'm so excited about the math that I just need to do. So every now and then I'll pause and I'll check my math. So negative 6 times x is negative 6x. Negative 6 times negative 2 is positive 12. And then I subtract. So I'm going to add the opposites. So that negative 6x is now positive. That positive 12 is now negative. And then I subtract. These two cancel. Oops, I forgot to make this a plus sign. These two cancel, and then so then I get 5 minus 12, which is negative 7. So here you were supposed to write the multiplication statement. I'm not going to do that with you right now because you already know how to do that. What I'm really interested in is in taking all this information and moving it down here for our number 6. And maybe I put it on this side so that it's cleaner. All right. Okay, so let's see, let's put this right here. Okay, so there's one more thing that I want you to recognize, and then it says this is this. Now they want you to find f of 2 and compare it to what you found by f of x. Wait, what? Oh, they want us to plug in 2 to this big function right here? Yeah. Okay, so let's do that really quick. So everybody, wait. Did I mess something up? Where'd I go? Here? Ah, man, I did mess up. Man, Ms. Johnson, sorry guys. Thanks for having my back. All right, so yes, sorry, this was negative 2x. I should have checked that line. So all that was wrong. So this is wrong too. I apologize. That was not a mistake on purpose. So then this would be negative 2x plus 5. So then I get negative 2. So I get negative 2x and then 4. And then I would change the opposite signs. Right. So then my answer is 1. Okay. Let me check again. If you could check my math again, that would be fantastic. Sorry. I'm trying to get to this part right here. Thank you. Thank you. Thank you. Both of you. Thank you. Man. Sorry. I'm trying to find my pencil to give you guys credit. Appreciate it. All right, here we go. So then they want us to plug in f of 2 to here. Okay, so you want me to plug in f of 2? Yeah. So I'm going to say that this is f of f, and I'm going to plug it into 2. Okay, so I go f of x is equal to x cubed minus 4x squared plus 2x plus 5. And I want to find f of 2. So 2 cubed minus 4 times 2 squared plus 2 times 2 plus 5. Okay, I'm going to scoochie this over so you guys can all see. Does everybody see what I'm doing right here? Okay. Then the next thing I want you to do is I want you to evaluate that. So go take a second to either do it by hand or put it into a calculator and tell me what you get. This is important. So go ahead and pause and do that. Okay, so some of you already finished and then you calculated it. And so you got, so I'll calculate as well. Hopefully my math skills are a little bit better this time. So 4 times 4 plus 4 plus 5. 8 minus 16 plus 4 plus 5. So that's negative 8 plus 4 is that's negative 4 plus 5 is 1. F of 2 is 1. Okay, so I did both of the things that they said. And it says, find f of 2, done. And compare it to the remainder you found when you divided. What's our remainder? Where's our remainder here? Yeah, it's 1. Oh, these two things? You want me to compare this to this? Okay. What do you see? What do you notice? Yeah, they're the same. Oh, Ms. Johnson, so how can I use this? So that should always be your question. Like, hey, Ms. Johnson, how am I going to use that to my advantage in making sure that I I don't know what the right word there is. I can use this to my advantage to learn math better, check my answers better, something, right? And I say, yeah, absolutely. So first of all is understanding that this is the same. So I'm going to write that in a sentence really quick, just so that we're all on the same page. We saw that the remainder equals to f of 2. That these are the same. And the reason why they're the same is not coincidence. the reason why they're the same is it's not coincidence, it's more by fact, right? Let me just highlight this so it stands out. Okay, then they want you to try it with another set and then compare it to f of x over x plus 3. So what do you see? And then guess what you're going to see? Everyone says what? They're the same. Exactly. So based on these two examples, we're gonna say that the remainder is based on that function. So is f of 2? No, actually, wait, actually, ask that question again. Very good. Okay, so someone asked, so if it was a different x, would it be the same too? And you're asking the same question that someone else is asking. No, I can just copy it. Someone else asked the same question just in a different way, and I like this question just a little bit better, so it's a little bit more it's a little bit more in everybody's face. So when someone asked this question in the chat, but someone else asked a very similar question. So is f of 2 here related to the -2 here, x minus 2? And yes, it's related, because look down here, f of -3, is it related to x plus 3? And you're all like, yes. So we noticed that the remainder, when you divide by x minus 2, is equal to f of 2. So to write that clear and more plain, we would say something like this. We saw that the remainder when dividing f of x by x minus n is equal to f of n. So yes, these two guys are exactly related. So this is the job that I really would like you guys to develop, is like, those are the same. I wonder if that's a coincidence. And then in your mind, you're almost like arguing with yourself. Oh, I wonder if that's right. And then you try another example and you're seeing a trend, right? And then you make a conjecture that is based on that trend. Okay, so that's what I really wanted to share with you. This helps you a lot as we go through the rest of this unit. But the biggest thing that I wanted you to get out of this very short video goes like this. When I'm dividing and all I want to know really quickly is the remainder, I don't need to do all this work. I mean, actually, I will, like, what do you prefer, right? Do you prefer, if I said, hey, I need you to find f of 2, and you already did this work, well, just grab the remainder. Let's say you didn't do the work and I say, hey, find f of 2. That means you could just plug it in here, right? Like you've been doing in the past. They really want you to recognize that these two things are related and they're exactly equal. Good job.